Good morning. Welcome to the PERC meeting at the IETF 99 at Prague. So Prague is a bit special for PERC because this is where PERC started in IETF 93. So we're back here again. Let's see what we can do today. Next slide. So Notewell. There's been some changes in the Notewell. Not a lot, but some things that you highlighted there basically says that if you're in a BOF session and say something, then that belongs to IETF as well. So please remember that. And one more change is on the RFC. There are two RFCs that spoke about IPR. There's one, both have been replaced by one RFC. So if you have any questions on how the IPR applies to PERC, please have a look at that RFC. Okay, moving on. So what happened since IETF 98? Richard Barnes decided to step down as the chair of the working group. So he'll be an individual contributor to the PERC working group. And we want to thank Richard Barnes. Personally, I would want to thank Richard Barnes. Thank you. Then welcome Niels. Niels is from Mozilla. He has been in the real-time development world for more than 10 years now. And he's been one of the core developers on the WebRTC stack in Firefox. And also he has been active reviewer of most of the PERC documents. So he's involved in the design of it. So he also knows a lot about PERC. So welcome, Niels. And we had a virtual interim between IETF 98 and 99. The idea was to kind of close open issues with PERC right now, which corresponds to the repair packets. One thing that came out of the virtual interim is that we all agreed that RTX could not be done the way it's done today. You have encrypted packet in PERC, and we need to do RTX on that. So if not a big progress in the virtual interim, but at least we all came to the same conclusion. So today is giving RTX another retry and see if you can close some of the open issues with PERC. Milestones. This is for the working group and our AD. Our milestones expired, and that slipped my mind, so sorry for that. So next slide. So this is a new proposal. If the working group thinks this looks good, we can work with the AD to get those things added. So what we are trying to say here is that by December 2017, we'll try to get the SRTP specifications and key management at least submitted as a working group last call or IETF last call. And then by March 2018, we'll have the other documents submitted. So if everyone thinks this looks doable, let's get it in. Any objections? Okay, I'll take that as a acceptance. Next slide. Again, a recap of milestones and documents. Those things that are bolded are the ones that's been in the working group for a while and got quite a bit of review, and also have been accepted as the working group documents, and also been reviewed by some security area folks as well. And we, as a typical IETF process, we would want to kind of close any open issues with those documents so that we can make progress in the working group. And there are some other documents which are individual documents. Once we close the open issues, we would want to handle those documents as well. Next slide. So agenda for today. We have 70 minutes roughly for Cullen to talk about the open issues with PERC today on the repair packets. I think he has a lot of slides prepared for that and good amount of time. And then we have Paul talking about both tunnel and framework, because David is not here, so he'll be talking about both tunnel and framework updates that happened. And if the time permits towards the end, we would want to see, based on how the discussion goes today, how do we want to move forward? Because the idea is it's been a while that we have made a real progress in terms of the document moving forward. So we want to kind of see where we are with the open issues and what do we conclude by the end of this meeting, and see how the working group as a whole wants to work towards that. Next, finish. column.
Okay. So good morning, and I'm very hopeful that we're going to make more progress than we did in the interim. We learned a lot of the problems at the interim. I straightened out my thinking about how RTX works. Okay, so well, how I'm going to sort of set things up today is go through, our big open issue is this RTX FlexVec red, how we deal with all of them, okay? And I'm going to go through some different design proposals for that to sort of cover the design space a little bit. And I want to try and stay, largely to just exploring the facts of what these design proposals are, not really dig into the pros and cons and arguments about what we should choose. Have a look at all of them. And then after we've sort of gone through them, and I think they're all grouped, and we've seen the sort of variants of all of them, then I've got a proposal from Sergio and I about what we could live with that we think would probably be a good path forward. So let me start with that. So the first thing I want to touch on a little bit is this light draft, and just hitting a little bit what light is. And I gotta say, I'm mostly derived this from looking at code, talking to other people, bringing information together. But I think the way to think of it that I didn't understand was it really is easiest to think of it as a separate SRTP encryption and context that is doing SRTP, and the output of that is tunneled inside a separate and different SRTP connection. The first one of those two is set up by keying through the JavaScript, sort of similar to SDS basically. The second one, the second SRTP is set up through our normal DTLS SRTP handshake like we would do if we weren't doing anything with PERC at all. So I just wanted to hit that. At the top level, that's the basic approach of that design, and that'll help it make more sense as we pull it into the more detailed things of that proposal. So next slide, please. Okay, the first one I want to talk about is FlexVec. Now, FlexVec, nothing to do with PERC on this slide here. This is just about how FlexVec basically works. Okay, it is reasonably clear that it can either do FEC on the unencrypted data or the encrypted data. One way happens by default, and you would need signaling to specify the other direction, okay? But it was designed from the beginning to support both of these types of modes. In general, the default mode for all things RTP that are vaguely FEC-ish is to do it before the encryption on the sitting side. So next slide. So on FlexVec, and you're going to see the same thing on the other ones here, we're going to have basically three designs. You could do you could do the repair or whatever you were trying to do after the encryption, before the encryption, or somewhat in the middle of the encryption, which is the light proposal or the shim proposal from previous ones. These are all the same sort of thing. So we pretty much covered the design space here, and so let me talk about each one of these after each other. So just to explain these and so that you understand how I'm drawing these diagrams. These are all of what the Cinder is doing. It's fine. It's all about what Cinder's doing. In here, I need to stay in the mic. Well, we probably have remote. I got to stay in the pink box, man. We have inside of the SRTP double box is the end-to-end and the hop-by-hop crypto happening. The output of that is cached, used for repair, and then packets that are repairing things because they're operating on already encrypted data. They'd only do when they were encrypted. The algorithm would be set that they're encrypted like RTCP, and that they're only done hop by hop, not end to end. Okay, so that's the A design. The B design, largely roughly the same, except what we're repairing is the raw media before it's encrypted. That's what goes into the cache, and then it would be double encrypted. Now, this, unfortunately, this design B here is the default way that RTP works if you aren't doing anything else. Like the RTP spec says, like in general, things are that unless some text somewhere says they're otherwise. This case, we all agree that the media distributor cannot do repair in this case, okay? So the one default case for RTP is the case that definitely won't work. Okay. Now, the last case here, light, the first SRTP end-to-end encryption is that first one that we were talking about before, the first SRTP session. And then there's the second SRTP session, which is the hop-by-hop ones. And what would be cached is the intermediate result of that, that's been end-to-end encrypted, but not hop-by-hop encrypted. Later, when the actual repair packet's sent, it's hop-by-hop encrypted down here at the bottom. Now, we all agree that both of these designs could, technically work, right? Like the media distributor will be able to do the type of things it would want to do, and they would both, we could write the protocols to make them work. So I'm not going to delve deep into pros and cons of those right now, other than to say that we agree they work. Certainly, some people feel that this would be more work to implement in Chrome in particular. So it's a implementation, how close things are, those types of things all come together. So, okay. This steps into it just a little bit more to show the differences of some of the stuff I just said on the last slide. I want to say on this slide, but whatever. Just a little bit more of the differences. So one of the other things that's going to happen on this is because this A plan, which has occasionally been called triple, has ended up, it's a joke about it, right? We had an end-to-end encryption, a hop-by-hop encryption, and another hop-by-hop encryption. So when we get to I'm going to get out of the box occasionally, you're just going to have to pick up on me. So over here, when the media distributor wants to decrypt this stuff to do FlexFAC and do repair, it has to undo this hop-by-hop encryption number 2, and it also has to undo the hop-by-hop encryption that would have happened in number 1 right there. Okay, so it's 2 of those. This solution down here, it's there's only been one hop-by-hop, right? There's only the end-to-end, so it only has to do 1. And we've talked about this. I don't think any of us believe that the encryption time is a big difference here. The basic issue is this only happens on a small percentage of your packets, which are the repair packets, and the crypto we're using, the SHA-1, the NIS, on a modern Intel processor, that happens at the same speed that you can mem copy data. So I don't think that we've been arguing that the encryption time was a major difference on these, but people have been talking about the complexity of implementation, particularly in Chrome. Hello. Okay. Sorry. Supposed to touch the microphone. So, stepping into RTX, it's a pretty similar story here. So keep in mind, though, this middle way is how RTX says it works. And so if we go to either of these A or light solutions, we do need to write some extra text that says when you're using RTX in this type of environment, it's a bit different, and here's what happens, and explain whichever it is, the A or the light. Any questions about this? Okay, next slide. Red. So I was trying to find a little overview of how red works for people. So typically, what red is typically used for is audio packets. It's not actually defined from video. People have used it from video, but it's not really defined there. And what they're doing is they're sending the high quality audio packet for a given time frame. And at the same time, they're sending a much lower bandwidth packet of the audio from the previous frame. So that if the previous frame was lost, now then in this new packet, you can do the packet repair of the previous frame, and you have the current frame. So this is basically trying to show we're sending packet 1 and then in a high bandwidth way, and then later a low bandwidth version of it gets pushed in with 2. This protocol seems to have been unedited since it was largely published back when it was first done. This slide is courtesy of Colin Perkins from IETF 99-PERC-20170718-0930, sort of dates this. Next. So there's a couple ways that this might end up being used in a PERC context. The first one's pretty simple and is pretty classic, right? The endpoint is perhaps doing redundant encoding with a high bandwidth and a low bandwidth. And what I'm trying to represent in that packet coming across from the endpoint to the media distributor, the H1 is like a high bandwidth version of packet 1 in the stream. And it also carries in the same packet a low bandwidth version of the audio that was in packet 0. And the media distributor can forward those on out to the endpoints. The endpoints can do repair, and it's end-to-end. That works very seamlessly. Now, people have talked about a slightly more complicated use case as well for PERC, where the endpoint is sending to there's a couple variants of this, but this pretty much covers all the important ones. The endpoint is sending to the media distributor not a redundant stream. It's just sending high bandwidth packets, H1, H2. There's no red involved at all. The media distributor is perhaps just sending the same thing to the endpoints. And it starts noticing on this endpoint here that it's having some packet loss and decides, well, let's start doing redundant audio for that. Now, in no way is it going to be able to access the audio data to be able to create a low bandwidth version of it. And none of our codecs support you could design a codec where you might be able to make a low bandwidth version on the encrypted data or something, but we don't have anything like that. So they're going to be sending the same high bandwidth data twice. And that, you got to be careful anytime your approach to congestion is to double the bandwidth of something. But I think what people, that sounds funny when I say it, but in fairness to the people who do this, I think what they do is they'll have like 800 kilobits of total bandwidth, maybe 100 of that's audio. I'm just making up the numbers out of the blue here. And they suddenly decide they want that the conference is going to crap, and they're going to up the quality of the audio, and they're going to down the video. So they'll double the bandwidth of the audio, but they'll substantially reduce the bandwidth of their video at the same time so that they don't have this sort of congestion control craziness. But anyway, there's lots of dragons to be in implementing this stuff. Does that make sense?
Because if you double the bandwidth of the audio, then they won't lose any audio. So why do they need to send it twice anymore? There won't be a congestion problem anymore.
Sorry?
Yeah. You reduce the video, why do you need to send the audio twice? Is what he asked.
Okay. I think the idea is if the congestion was basically, let's say that the congestion was on a link shared by many people, and that what your total impact on the link is actually fairly small, and that the link's experiencing a 5% packet loss rate. If you start doing redundant encoding with a 5% packet loss, you're going to basically have almost no lost packets. You're going to have a slight increase in latency to your call, but you're really not going to have any blips in your audio. But to do that and not be utterly insane from a bandwidth control point of view, you've got to remove some bandwidth you're using for video for that to make sense. Does that answer the question, Ronnie? Okay. Next slide. So redundant encoding is in all of these plans done by basically, let me start to the top one. We take the RTP packet, we encrypt it, we cache the double encrypted version of the various packets in time, T0, T1, etc. And in fact, we never send the original packet all by itself. It's always going to be packaged in red. So it's sort of like it's always a repair packet. So then we form the red packet, which takes these two T0 and T1 packets and gloms them together into one big RTP payload in a way that's defined by red. And then that's hop by hop encrypted because the data is already done and it sends it out.
Magnus Westlund, does this really work? Because what red takes is payload types, and payloads according to payload types. And your SRTP operations you do on the created packets. So I was wondering what data you have in the cache.
So it would be encrypted data, but keep in mind when we encrypt, let's say I've got a payload type for G711 and I'm sending it over SRTP. I mean, I don't change the payload type when I encrypt it.
No, but your IV is lost.
So
your IV. The IV for that SRTP packet doesn't exist because you never get the headers.
You never get the, right. So the headers, no, just a minute here though.
Yeah.
With red, the primary, the information is going to come from the primary, you understand the offset of what the sequence number is of the other thing, so you can recover the sequence number, which effectively allows you to recover all the information you need and the times. Yeah.
Yeah. Okay. So you're okay. I have it's gonna be dragons there, I think, but yeah. Yeah.
Yeah. I guess it's a good point. This doesn't change much from.
This is, I mean, you need to write a lot of, I think, not a lot, but you need to write specification text for how you actually recovered. Yeah, okay. You need to recover how you recover the packet.
Yeah.
And the IV, etc. in this case, and how you strip it and what, so you don't lose too much information you can't recover, because I think you need to go through that. I'm not certain it's that trivial.
Look, on all three of these, I think that you need to, this is a sketch of how it was. We'd need detailed text that showed how each one of these worked. And I think this works, but I agree it's not one sentence in the draft, that's for sure, right? Again, the way that red would normally work is the one way that would not allow the media distributor to do anything. And in the red case, we could choose to go with that. Just say, like, look, you can't do red repair in the media distributor. You can only do it sort of end to end. That, you know, this is not a, we can't choose red B. We could choose red B. With light, it has probably nearly the same complexity in writing that up. It's nearly the same text between red A and red B to talk about what changes to red to make it work on the encrypted data. It's not double encrypted, but single encrypted, and would work roughly the same. Okay, next slide. Proposal. So, what we've been talking about here, I've been talking around various conversations, it's been suggested on the list at various times in various ways, is about taking the information that is in the OHB today and instead moving that to the payload. So we'd no longer have to negotiate an idea. So first of all, let me explain how it works and then talk a little bit about pros and cons of it. So right now we have an OHB header. It has a length. Based on the length, you can tell what fields are in it. It can have a couple different fields, a couple different combinations of field of the things of what it's changed, and it carries the original sequence number in this case, or there's some other fields put there. So we'd replace that. The length sort of gets morally replaced, or the equivalent of the length is a new bit field. And depending, if bit 0 is set, it means after this you find the PT. If 1 set, you find the sequence number. So it's the same thing. There's something that indicates.
Okay, so let me just make sure I understand this diagram. So in the top thing, the first big box, the larger box, is the entire RTP header, and the thing, a smaller box on the right is the encrypted is the RTP payload. Is the RTP payload?
Yes.
And in the new diagram, the smaller box with the dots in it is the RTP header, and the thing on the right is RTP payload. Good.
Right.
Okay, fantastic. So the length field of which you're in the new one, the length field of which you're talking about, is drawn in the RTP payload, but you said the length. You said so. Which length field is it? It's not the RTP length field one trusts.
Sorry, there's no length field in the new one. No, there is the RTP header extension. So that's the length of the RTP header extension.
Yes.
And down in here, there is no length.
Okay.
There is just this bit field.
I see. So when you say replace, you mean don't use. You don't mean take that byte offset and stop.
Oh, yeah, sorry. Okay. Yeah. Okay. Well, what I mean is, in the spec, we throw out the OHB, and we invent this new text that carries roughly the same information we used to carry. Yeah, okay. So the bit field is always there. And then depending on which bits are set in the bit field, you will find a variable, you'll find either the sequence number or the PT or whatever here. And then after that is all the encrypted media, just as it was up there. We've largely taken some of this information and shifted from the header to the payload. That's largely what's happening here. Does that make sense of what we're proposing before we talk about why? Ronnie.
So does it mean that you'll now define a new RTP payload specification? Because the moment you put it into the payload, that you need an RTP payload format for that, because it's not the header part, because inside it can be different RTP. You create differently a new payload.
Yeah, I get what you're saying. That was my first response too. I was like, hey, we can't do that. It's a different, it's no longer an RTP packet. And Sergio, he really cleared up my thinking on this, and I think he's got it right, which is, no, these transforms in SRTP substantially change the payload of the packets. They add tags to the end. They add, here we're just adding some information to the beginning. And when you go to decrypt it, the same transform that decrypts it knows how to remove all of this information and return it back. So don't think of it as we're changing the payload. Just think of it as the encryption process adds some metadata to the front of the encrypted data and later removes that metadata. And the metadata has to do with what's allowed to be changed and what's not.
Jonathan, I was going to agree. This is part of the crypto transform, not part of the payload. And I mean, I could bike shed it and say, well, crypto transforms typically put things at the end, not the beginning, but I'm not going to bike shed it yet. I'll wait till we have an agreement on the general approach.
I don't think anyone would be concerned with that particular, but yeah. That's
Ronnie, just to clarify, because what will we write in the SDP? I mean, how do you describe this in the SDP? Because the SDP you have to give a payload type number and the name of the payload, okay? But now you can't do it H.64 because any entity that will look in the middle will be confused by that. It will try to do it as an H.
So, do you want to answer this, Richard, or you want me? Okay.
So Ronnie, when SRTP transforms, as has been said, like they add overhead to the payload, right? They add auth tags. Okay, maybe I'm misunderstanding. Well, the thing I got up here to emphasize was that this really is internal to the transform, because whenever this is, the thing that actually appears on the wire, this chunk that's added to the beginning is encrypted, so it's not visible to anything that's looking at the packet.
Yeah.
Are you still addressing Ryan's question? Because otherwise I want to ask. Okay.
Yeah. So basically what I'm saying is, I mean, you negotiate it as, the negotiation is the payload type is H.264, and then the crypto transform, which, presumably you're negotiating DTLS, but if some insane person wants to do PERC with SDES, you'd negotiate an SDES, would say, double, and then this is the inner half of double.
Well,
Well,
let me put it a slightly different way. As I said, the thing on the wire is just opaque bits, right? It's just random stuff. Nobody's trying to interpret that. The thing that goes in and comes out of the SRTP layer is the payload type you expect. It's H.264 or whatever. It's just after that gets shoved into the SRTP layer, this extra stuff gets added as part of that encryption process. So the payload types that are actually visible to the external world are the same payload types as ever. This extra stuff just gets added as part of the wrapping into SRTP. So it's never visible. It never changes anything that's visible outside of the transform.
And to be clear, this is not really in any way signaled in SDP. Like the SDP, if you were doing normal single encryption or double, remains the same. It's the DTLS negotiation that negotiates the protection profile that TLS is using. And when that protection profile, instead of being ASGCM whatever, is double, then this transform knows to do this both when encrypting and removing it when decrypting. There's one other little thing here that's sort of a side thing that I don't want us to rat hole on too much, but I do want to just try and check with the working group and see if we've got consensus on it or not. I couldn't really follow what happened on the mailing list. And this is the IM flag. So I added an IM flag here. And the use case is when VP not. Do you want to come talk about use case? It'd be awesome. Thanks.
Yeah, the flags need to be there because when you are doing VP9 SBC with scalability selection, you can drop the later layers of the frame. So then you have to move the M flag for the latest packet to a previous one. So if you drop the layers in this view, you need to modify also the M flag.
So Mo, a question I had for you was, if you're doing the marker flags, do you not need this? Does that solve the problem for VP9, or do you still need this? Do you know? Do you need to be able to have the SFU change the frame marking bits, or the M bit? If you're using frame marking bits, can you get away with not having the SFU change the M bit? I guess the question.
Moshe, so in frame marking, it's not expected for the SFU to alter the bits. It's expected for the SFU to interpret the bits, and so they're generated by the endpoint to help guide SFU decisions. When you talk about M flag here, you're talking about literally the marker bit from the RTP header, and what in VP9 needs the marker bit?
Well, in fact, frame markers should not go from the media distributor to the endpoint, because they don't need it. They will decrypt the media and they will have access to the media. So if I were going to use it, I will not send the frame marking from the media distributor to the endpoint. So when you are doing VP9, the SBCs with the scalability selection, you will check the frame marks to see if they have changed now the semantics, but if you say that the layer frame is with this the scalability, the scalable layer. So if you drop it, none of the RTP packets of that frame, of that super frame, will be sent to the endpoint. So if the last packet of that frame has a mark, you have to put it in the last one that you send.
Right. So, Jonathan, yeah, this applies to any spatially scalable format. Basically, the idea is that in frame marking, the end of the E-bit means end of layer, and whereas the M-bit in the RTP header means end of picture. And in particular, this lets you know when you've actually got the top layer of the picture, so that if an SFU is stripping spatial layers, this lets you know, okay, this is the last layer of the picture, I should go ahead and display this now.
Mo again, but I mean, part of the whole point of scalability is that the whole point of scalability is to be able to drop layers, and if there's independence among the layers, that's something that can be signaled independently, whether or not you have, whether or not you want an indication of whether or not you're going to get more layers, and that's not really all you need to know is the independence between the layers, and whether or not you're going to get more layers that's a different kind of indication. That's like a rendering acceleration hint. Right? That's not a decoding. That's not a decoding requirement.
Yeah, I think that displaying the video frames is a very important part of decoding.
I mean, no. So if you look at a practical, anybody that's written a real RTP implementation knows that the marker bit is notoriously useless for almost all payload formats. You cannot rely on it for rendering acceleration. You can do a heuristic to see, is it reliable for this or not, but you can't ever absolutely, and actually the RTP specs say you can't. So I think you could infer this in the same heuristic without having an explicit marker for it.
Yeah, I mean, obviously a receiver has to be prepared for an SFU that isn't rewriting M bits, but I think a lot of people want their SFUs to rewrite M bits to be correct, so that you don't have to wait for the next frame to know whether you can display this frame or not.
Okay, so let me attack this from the other end. So it seems to be there's some argument for SFUs being able to do this, and let's look if there's any harm on that. And given the discussion we just had about, like, if a wrong M bit causes you harm, you're doomed anyway. I really don't think there's really any risk or security problems with allowing the SFU to set the M bit. I mean, that may be able to mess up calls in certain ways on some things, but the MCU could equivalently, or SFU could equivalently mess up things just by dropping packets or whatever, right? This doesn't extend the damage an SFU can do in any way. Doesn't give us access to raw media. So I see no problem in doing this, and so, so my feeling is we should, regardless of this proposal or OHB or however we do it, that we should probably move forward with adding this M flag. Is that, people in agreement with that? Okay. So that sounded like, can we please make sure that makes the minutes? We got consensus to add an in flag.
For the notes taker, we are saying that n bit can be modified by the SFU.
Which I think is a change from our previous decisions. Okay, so let's peel the next level of onion about this. This RT payload here is all encrypted, and the SFU can't modify it. It can't even read it. It used to be able to modify this header and add more things to the header. So if the client initially put in a header that said, hey, here's the original payload, but they wanted to change the sequence number, well, you know, the SFU just extended the OHB and added a sequence number to it. Life was good. Can no longer do that. The client has to set this bit field, and it has to be set to enable everything that the SFU will be allowed to change. It doesn't mean the SFU has to change everything that's in there. So, you know, one strategy would be, you know, set these bits all to 1 and like let everything be changed, right? That has a bandwidth impact for some people for audio and don't want to do that. So we need a way for the client to be able to know what bit field value to set when it's encrypting these packets. At the same time, it's the SFU that knows what it wants to change.
Jonathan Lennox, I think you're assuming that adding this OHB equivalent is part of the end-to-end transform. What if it's part of the hop-by-hop transform?
I believe the people that want this in the RTP payload.
What does in the RTP payload mean? I mean, it's clearly not in the RTP payload, right? It's part of a crypto transform, because as we discussed, it's not the payload. So, I mean, if should the SFU be able to read these fields? Your argument is it is useful for the SFU not to be able to read these fields?
The SFU has no need to read these fields or modify them. It doesn't need to in the slightest, but it does need to know which things it's allowed to. It needs to be able. There needs to be some coordination of what things are going to be changed at the broad level, right? Try my proposal here first.
Okay,
I see where you're going with that.
Yeah.
I will strongly disagree with that path. And when we get to the next slide of, you know, what we'll agree on, what we can change and what not, we can discuss pros and cons. But so proposal roughly is the client needs some way of doing this. That could be an API that just set it through JavaScript or whatever. There's many ways to do it. But one way that we would standardize it as a possible way to do it, not the only way to do it, would be the MD could tell the KD over the tunnel what this value was, and the KD in the DTLS in the DTLS EKT message, the extension that we put into DTLS that comes from the KD back down to the client where we pass the KE key, we would add another optional field there for the KD to pass this data back to the DTLS stack. And when you look at implementations, it actually all sort of lines up about how you sort of want it. You get this information out of DTLS, which is the same place that you found out that you were doing double in the first place. You feed that into the SRTP implementations, along with all the other information you got from DTLS, like the salt and the keys and whatever. It's just one more thing that gets passed along with that data. So it's all sort of in the right places and passed along the right path. It actually works out pretty well. And I don't want to say that's the only way of doing it. I'm just saying that would be one way that we defined it so that we had a full, complete story that worked. Does that make sense as a way to do it? Fair enough. Okay. Yeah. Yeah.
Ronnie Evans. So you said the MD decides what can be changed. That's what you're saying? I mean, but I thought we don't trust the MD. So why do you let him know what he can change? I mean,
well, the client the MD gets to propose what it would like to change, right? And the client gets to decide whether it wants to use the MD or not.
Yeah, but the client, well, how do the client know? I mean, it's something that, I mean, the client is stupid to that. I see.
So look, the information so let's jump back to this trust issue for a second. We have been very careful to not add to this list of bits in this thing the ability to change anything that we believe compromises the security of the system. So if the MD says always, I want to change everything that's possible to change, okay, some MDs will most definitely do, or some of the SFUs will most definitely do that, right? That doesn't I mean, PERC still has all the security properties that we expect PERC to have. It's fine. I don't see a security problem with that. The only issue with that is it'll use up more bandwidth than an SFU that said, hey, I don't need to change anything. And there will be SFUs that do not change any of these things, right? And that's been one of our compromises from the very beginning of the working group, was to try and support the people who want to change lots of things and the people who basically didn't want to change anything for bandwidth concerns. Jonathan had the comment that really the bit field and sequence number should be more put on the end instead of the beginning. As long as we can figure out how to find and parse those, I'd be good. But yeah. I think it's really bizarre. Yeah, let's say when we get sort down the next level of details of that, we will look at that. If it's possible and easy, we'll do it that order instead of the other way. I agree. Yeah, no, I mean, like I said, that's a bike shed. I don't actually care. I mean, so I think my proposal, when I was saying put it on the hop by hop, basically the high level is if the if we design these things such that, you know, that the this field is, you know, exposed to and rewritable by the MD, then you don't have to waste bandwidth on the uplink, even if the MD is adding another downlink. And then what this, and you know, if the MD decides to start lying about it, well, your end-to-end auth will fail and you won't get any media, and somebody will call up the MD and say, hey, what the hell? So. Okay, I think I could probably live with that. I'll think about that more. But let's see. Do other people have problems with that type of design approach if we went that way? I mean, we've had lots of implementers on the OHB say, please, 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 we want the client to put the OHB in and have it basically right instead of having the media distributor insert it. So, I think that one of the benefits of adding the payload in the end-to-end transformation is that the SVU does not need to change anything. I mean, you don't need to change anything in the MD to make it work. I mean, you just receive the data from one endpoint and you just transport it directly to the endpoint. In fact, we have implemented it in Janus and Jitsi just with frame marking, and it works. I mean, you don't need to change anything. The SVU does not need to change to care at all about the OHB. I mean, just get it from one side and put it to the other. I mean, there is a compromise in bandwidth, but this is just 2-3 bits, 30 bytes, and you are adding a 32 tag to the inner transformation. So just, I mean, you are wasting a lot of bandwidth anyway. Okay, so I think this, for me personally on this, when it comes down to it, I don't really like any of this. I sort of prefer the OHB, but I can live with this for sure. And if Emil and Sergio want for their implementation of the SFU to have it inserted, to have it not change, and I think that's been one of their fundamental arguments is, I mean, we've heard Emil say multiple times over years, like, I have something that just works now with no changes if you guys just refactored this crap a bit. And I'm trying to address that concern. So all of this, let's go to the next slide here for a second. So this really gets to the proposal of what we're proposing changing, or a consensus proposal on this. And this is all grouped together thing. I think with the group of us that sort of said we could live with this, we can live with this, but not bits and pieces of this. It's all or nothing, right? That was part of how we came to some level of agreement, because there's parts people like, parts people hate. So the proposal is do that stuff we were talking about on the previous slide, of moving it into the payload header, and we can modulo the bike shed details of that. And go with the lines that were A for red RTX and FlexFec in the previous designs, and certainly well aware of Magnus's comment that like non-trivial text required to make those things happen. And then the last one on DTMF, and I don't think anyone cares about this one deeply, we could change this one, is DTMF will be dealt with as end-to-end media. It is not something, #6 to mute your WebEx conference is a bad idea, and everyone should stop doing that, right? That'll be basically the implication of this. So that's the proposal that we've got going forward here that we all think we could live with. The question is are there people who have some reason they couldn't live with that proposal? Let's talk about that.
So I think we have been on this issue for close to more than two IETF meetings, and right now what I'm hearing from Cullen and Sergio and others is that they have a proposal that they can live with. Both the double and light, they have come up with the proposal. So if the working group kind of thinks the 3 points that Cullen has raised, if they think they can live with it, chairs would want to know the consensus here. So do we want to go one by one and kind of get a hum on it?
It's a take them all through. It's one hum. It's not.
Okay. Yeah. Makes sense.
What we can live with is all of that, not part of that. So
I agree. Good point.
Paul Jones, shorter than everybody else in this room, I guess. So just one question for clarification, and this is something that Jonathan raised. The moving the OHB into the payload field, what was described initially, I think, was that that was going to be placed. So when the encryption transforms call is going to be inserted, then the hop by hop encryption performed and end-to-end encryption performed. But if we do that, the receiving endpoint won't be able to decrypt it. So that will have to be done in the middle, in between the hop by hop and end-to-end, unless I'm confused about something.
You're saying if the hop by hop keys are different?
No, I'm saying that field, what used to be called the OHB, that's on the payload, will have to be inserted between the hop by hop and the end-to-end encryption pass.
Yes.
Okay.
Okay.
Which that's where in the transform, right? You know how we do the steps where you do some of the stuff on the packet, then you modify the values and do the other stuff on the packet, right? From just an integrity point of view. This happens at that same place in between those two stages.
John, thanks. I mean, the one thing I'm unclear on this proposal is how exactly is this? I guess it's still an original header block. It's just not a header extension. This new OHB, how does that participate in the FEC and RTX? Is it in the FEC and RTX packets or not?
Yes.
What? Yes, it is and is not?
Oh, sorry. Yes, it is. It's quantum. No. Yes. Okay, so you actually are doing FEC over the OHB. And I guess that might argue more against my previous thing of putting it, not putting it in the, of saying you don't have to send it up from the original thing. So I guess it doesn't need to, needs to be in the, that's an argument for setting it up from the original clients, I think. So well, I think that this proposal to work has to be set by the original clients. I think it's very, maybe there's a way to design it so that the middle could modify it, but the way I had run through in my head and tried to check with myself that I believed it would work, and the way we were all thinking about it was definitely, it was set by the client. Okay, yeah, I mean, I think, my response to this proposal is, I tentatively yes, but I'd want to see it, I want to see it fleshed out a lot more before I say I'm willing to, definitely, say this works, and ideally, rough consensus and running code. So if you could do a SketchUp of get this to work and I'm not promising running. Well, I mean, Sergio may actually promise you running code. I don't think I can fully. I don't need production level running code. I just need test bed. Yes, we actually have sample code that makes the algorithms work and that can actually reconstruct the original packets in all these repair cases. Yeah, and look, I think in any of this, it's consensus is at a point in time, and we're talking about here when we write down the details of this draft, we may find a gotcha that none of us are thinking of that causes us to have to come back and rethink this. I fully understand that.
Yeah, as I think I posted the list, I have a version of the last round of double working in libsrtp, and I think it should be straightforward to convert it over to this so you can at least see how it works at that level. So verify that the transform works, and we can get the configuration information.
I want to see the repairs.
Yeah, that's that I don't have the code for, but yeah, do what I can. I just wanted to confirm my understanding here of the order of operations here, and kind of where this new OHB goes. So is the order of operations here that you take the original payload, you do the encryption over the original packet, you append the OHB to that, and then you do the external transform. That's the order of operations. Okay, good. I thought it had to be that way. I just wanted to confirm.
That works. I don't think anything else does.
Ronnie, I'm going back to the SDP issue, because if you have header extension, you negotiate it. Here you don't negotiate everything. You assume that this must be there in terms of when you do EKT, you'll have to have this payload part, the new bit field and sequence number inside the payload. It will be, it must be there.
Yeah.
It's negotiated DTLS. Yeah, it's negotiated the DTLS.
For the remote people, Jonathan said it's negotiated by the DTLS. Exactly right.
Mosinati. So I can definitely live with this, but I think maybe it seems very sideways to me, not a clear advantage. So I think what may be missing from that list of three points of the proposal is that I think the motivation for this is really not on here. The motivation for this adds a fourth bullet that you don't want to deal with RTP header extensions. You don't want. I think one of the tenets of Light was we don't want to allow RTP header extensions to be anything in PERC. They're just regular hop by hop things that you can always manipulate. There's never anything that you have to put in RTP header extensions for and preserve end to end. And that I think was why it was put from the header extension into the payload. And if somebody ever wants to come back and say, oh well, there are some things in RTP header extensions that we do want to preserve end to end or have, then it would kind of defeat the reason of why we ever wanted to move it in the first place. So to me, it seems like kind of a sideways change without having that as also something that's agreed upon as a requirement.
My co-conspirator here behind you to answer that.
Well, there are several reasons of why originally choose to do that way. First is I didn't want to handle to cover and to care about header extensions and the OHB. Second, that I don't think that it is wise to introduce a concept of ordering in the OHB in the header extensions that we were going to do. Depending on what you put, the OHB, the extension mean one thing or another. I think it's a huge change of what anyone is implementing today. And also, we could even implement end-to-end header extensions or data, but put it into the payload anyway, because it is where it's meant to be. I mean, if you put it as we have a bit field, if we find any use case that we have not found any today, that we need to carry some data from one endpoint to all the other endpoints, we could extend that embed and also put it in there. So we are not preventing the usage of sending end-to-end data as we are doing the end-to-end header extensions with this proposal.
Yeah, I think I was going to say basically what Sergio said. I think in this proposal, I think as we've drafted it here, you do lose the end-to-end, the ability to have end-to-end protected extensions. But that said, the mechanisms in Double right now is kind of lame and not really implementable. I think as Sergio said, like if there is a desire, if there's a use case for this mechanism can be extended to add the stuff you would need to have some end-to-end protection.
Yeah, we'd add one of the bits in the field indicating that there was an offset header that said what the end-to-end crypto went with. So we can certainly have that if we want it. These guys, I had previously argued that there were RTP header extensions that should be end-to-end protected, and the example I had was the video orientation CVO. And I think these guys, successfully convinced me that I was just being idiotic. That if the SFU wanted to rotate your video on you, that was really not the go beat your SFU vendor, right? I mean, it's not a security risk of the type of risks we're trying to protect from in PERC. So, so that that's one of the parts that I just decided I could live with.
Okay, I think Cullen, this was your proposals.
Yeah.
Okay, so coming back to the Chair's dream come true time when we ask for consensus. So I think what I've heard from individual is that they're like Lennox, like Jonathan is tentatively S, and Mo and others, they think S, but we need to go back and have the authors kind of write and flesh out the details. But to get a rough consensus in the room and also in the JavaScript, like chairs would want to kind of ask two questions. One, if you are tentatively supporting it or strongly supporting it, hum. If you hum now, these are the two questions. That's the first question. Second question is if you're strongly opposing hum. So to start with, who supports tentatively also strongly for this proposal that has these three pieces in there? Okay. And how about the other one where you're strongly opposed to this proposal? Matt, anything from JavaScript? No. Okay. So for note takers, the next step would be the working group has accepted this proposal, but the authors should kind of go and flesh out the details, and we'll come back in the next meeting or in the interim. Yes. Yes. Confirm it on the list. Yeah. Exactly. Yeah.
Okay. Next slide.
Thank you.
That's really great. That was the hardest problem we have to deal with in the working group by far. Thanks everybody who spent the time to let me understand their issues and make this happen. Okay, EKT. Next slide. There's no open issues with it, so, but given the consensus we just had on the previous one, we do need to add an extension in here into the DTLS EKT message as a way of carrying this bit field value in EKT. So we'll make that change to the next rev of this draft as well.
So this is a minor point, but I think we may be able to get away with putting that, effectively putting that bit field value in the protection profile ID. So we may be able to get away without this octet. Yeah, we can figure that out on the list.
Yeah, that would work fine too. I guess it's just a question of the transfer that information somewhere across that link, I think is what I want to deal with.
And in that case, you would do the negotiation between the MD and the KD as to what the MD needs to be able to change would happen as part of here's the protection profiles I support.
We'd need to update the tunnel draft as well to be able to carry that information.
Well, no, you wouldn't.
Oh, no, you wouldn't. You would get it for free.
The profile.
Oh, yes. That's a much better design. Okay. That's some of the best design happening at the mic I've seen today.
The one thing I'm a little, a little bit concerned about is exactly what we need to explain exactly what the future extensibility here works like. What happens if I say, hey, I want you to be able to change bit 6, and I have no idea what bit 6 means. Is that a fail? Is that we have a way to negotiate that down? Is that or if, or worse, if I say, hey, I'm going to be sending you payloads with bit 6 set, and you have to know how to skip some unknown number of bits in the header.
So shilling for Richard here. Richard's proposal is that we make each one of those different combinations of things you can change be a DTLS protection profile. So the client in the DTLS messages will advertise up all the things it can support. The key distributor will choose the one it wishes you used, and we'll have a normal handshake and we'll get it. So my way of just transferring his optional data would have failed the test you just said, but Richard's proposal solves that problem, that it's properly negotiated between what the client and the can support. And that negotiation will carry all the way through the tunnel draft too, with no changes to the tunnel draft if we use protection profiles. So it sounds like I'm going to revise this slide right here to say we're not going to make any changes to EKT or tunnel. The only thing we're going to do is the way we define those will be the double draft will now, instead of defining just 2 protection profiles, it will define a bunch for the various combinations of what can happen. So you in? You want to see the details? Perfect. Okay. Next slide. So any problems with EKT that the working group has that we need to resolve before this goes to working group LESCO? Going, gone. Okay. Get lost, man. It's IETF. Okay, next slide. That's it for my slides.
Cool. Thanks, Colin. Thanks, everyone. Paul Jones.
Right.
Yes, that's right.
Okay. So so this is an update on the new and now potentially obsolete set of drafts. Maybe tunnel doesn't change, but the other ones probably will. So what's new? There's some editorial changes to the tunnel draft. We incorporated a DTLS, the TLS ID that got changed. The name changed. During the last meeting, we talked about introducing that to avoid having to have the conference identifier. So that got incorporated into the new tunnel draft, and then we addressed other comments that were raised during the last IETF meeting. So you can go to the next slide. So the DTLS ID will now be utilized, and so it's just to rehash what I just said. But anyway, the endpoints will be required to include the TLS ID and SDP. So that's just something to keep in mind. And the background, that's just for those who wasn't there for the discussion at the last IETF meeting. You can go to the next slide. There's an editor's note. Says the process through which the TLS ID and SDP is conveyed to the key distributor is outside the scope of this document. And the above text could be removed if we agree that the media distributor will always forward SDP to the key distributor. That said, should the media server take on this function, or should we have something else in the call control plane dealing with that and getting that information to the key distributor? My preference is that we take out the editor's note and just leave it as is, which says that it's basically out of scope how we get this to the key distributor.
Colin Jones, yeah, I prefer that too. There's a certain group of people who would like to get rid of SDP altogether, yet still continue to be able to use these types of mechanisms. So they don't want to create dependencies on SDP, but they're fine with us forwarding the ID, obviously. And if how you do that is forward all the SDP, that's fine for this. But I think it'd be better not to require something that's not really needed. So let's just say forward the TLS ID, however you do it. So
leave it out of scope. Okay. So I'll remove the editor's note. Okay. Next slide. Tunneling procedures. This is the revised. When I made some changes to the text, hopefully it makes it clearer as to how it works. There used to be a DTLS SRTP association tunnel affinity. That is, whenever you set up a DTLS SRTP connection, and through a particular tunnel between the MD and the key distributor, there was a requirement before that every message go over that same DTLS SRTP, or over the same tunnel, over the same tunnel between the media distributor and the key distributor. That requirement was removed. So if the media distributor establishes 5 different tunnels to the key distributor can send messages over any one of those 5. And that's made possible because every session is identified uniquely anyway, so it doesn't really matter which connection it comes over. So that was changed. There's a new text that explicitly states that mutual TLS authentication is required. I don't think that was there before, but it was intended, but it is there now. Required a key distributor to send an endpoint disconnect whenever certain events occur. So this is a way to know, for example, if the endpoint sets up a DTLS SRTP connection to the key distributor, but for some reason that fails, the media distributor didn't otherwise know that it failed. So now the key distributor can inform the media distributor that it did fail. And the association ID is now a UUID. Before, I forgot what it was, but we changed it During the meeting, I guess during the last meeting, it was agreed to make that change to use a UUID. So next slide. There's a bit of text on versioning. We only have one version so far, but we still have to discuss what we're going to do going forward. So there's a response if the key distributor initiates a connection to the media distributor. The media distributor sends over its supported versions. If it's not supported, the key distributor will respond back and say, "Oh, here's my highest supported version." So that was added. Also, the version field is only in the very first message now. We used to have it in every single message, so we took that out. So it's just in the first message. Next message, or next slide. There were some changes made to the protocol syntax to align with some of the previous discussions at the last IETF meeting. There's a shorter version length field. Put the message type before the message length, and then the version related stuff that I mentioned. And if there's anything else, I can't remember what it is, but those are the main points. Oh, the UUID field, or the UUID value that changed. I don't think that changed the syntax, but it may have. All right, next slide. In the example at the end of the document, there's an example of what the actual encoding looks like on the wire, just what one of the messages in binary format looks like. That was changed to use the now registered double code points. So we actually do have double. That may change as well, given just the discussion we had. But there is some code points registered for double, and we use those in the example. And I think that's it. So that's an update on tunnel.
And just to, like Eker had a comment on swapping the code points. Probably that comes into this one as well, right? I'm not sure. Eker, that was tunnel draft, right?
Yeah. I'm not sure it matters, but if I'm reading the diff correctly, you swapped the code points for unsupported version and proposed and supported proposals. Was there some reason for that?
You're talking about in a protocol.
Yeah,
I did change that. Yeah.
Was there some reason?
No.
Oh, okay.
I just felt like doing. I thought it was.
I got no problem with the numbers. I just wanted to make sure there wasn't something I was misunderstanding about, like why those other numbers were bad.
No, I swapped them.
No problem with that.
Okay. Cool.
See, I like attention to detail, though. That's I thought it wasn't that important yet since then.
Well, I thought it wasn't either. That's why I was worried.
Cool.
Yeah, like leaving the dollar in the
Yeah, I think framework. Yeah.
I was like on the so this is the media framework document. Certainly, if tunnel isn't outdated, I guess this one's going to be. But anyway, it's current as of before this meeting. So next slide. So there's just a few minor things that we did to this one. We introduced 2 new appendices. One of them is it's intended just to provide an overview of what the keys are that we're using in PERC, because there are several keys, and that does seem to cause some confusion. We have hop key and end key, and we've got some of these various other keys that are used in the system. So it just kind of provides an introductory text there, and we probably need to expand that more, so I welcome any input on that. The second one is the PERC packet format, which is definitely going to change based on the discussions at this meeting. But that's intended just to provide a high-level overview of what the final PERC packet looks like on the wire, because that was a little bit misleading. Having it broken out is a little bit confusing. So there's one place, and here's what it looks like. Then there's just some editorial cleanup, and probably don't need to go through the slides too much, but some of the editorial cleanup is I got confused with all the KI values, not because I couldn't keep track of the keys, but because the fact that there actually are multiple keys. For any given KI, there could be any number of other keys at the same time, because if an endpoint rekeys, its KI is now not there anymore. So it's actually multiple. There actually could be multiple concurrent keys of any sort in the system. So it got confusing. I just removed all that text. And so we just refer to the hop by hop key, the end-to-end key, and yes, the hop by hop key can change. The end-to-end key can change. An end-to-end key is more likely to change than the hop by hop key, but the endpoint can fabricate a new key anytime it wanted to, and then send that out in the RTP packet when it encrypts. So there's a little more language to explain the keys and the usage in section 4.2. So just a new paragraph added there. And throughout the text, I tried to change the EKT key. Sometimes it was written together, sometimes it was written separate. My goal with changing that was to try to make sure it aligned with the EKT Lite draft. So if you find any examples, the intention is EKT key with a space in the middle refers to the EKT key, the thing, and the EKT key with no space in the middle refers to the message EKT key that gets sent over the wire. So that's the editorial cleanup. And then the two appendices, you can go to the next slide. So Appendix A, this is the key inventory. We just list the keys that are used. So we have the KE key, the EKT key, and then they have the hop by hop key and the end-to-end key. So we've got those three keys, and then there's a couple of pages of text that goes on to explain those. Again, like I said, it's all new text. I welcome any input, suggested changes. It's just intended to be informative, not normative. I did move some text from the normative section down to the informative appendix that shows which entity has which key, because I think that's useful so people have an idea of who has what key. So if you can go to the next slide. So Appendix B is just the packet format, which now the OHB is in the wrong place, so that'll have to be moved. Otherwise, it may largely be the same, but this is just intended to show what the packet looks like on the wire. And the reason for that was even I got confused because I thought the EKT field was somewhere in the middle, but it wasn't. So that's that. I think that's all the slides.
So I think one of the nice things about the approach we've been discussing today is that I think we can just strike this appendix because at least on the wire, there's no difference between PERC RTP packets and normal SRTP. I mean, internally they do, but it's not visible on the wire. Well, in earlier versions, when the OHP was in an extension, there was a visible difference on the wire, and you had to negotiate it, as Ronnie noted earlier. But like now it's all inside.
Jonathan Phonics, yeah, it's all inside, but it's still useful to. I think it's still. I disagree that we should strike it. I think it's still useful to explain what's inside because it's confusing.
Yeah, my intent was to more or less draw a diagram like what Colin had up earlier, to put the OHB just above the ciphertext line.
Cool.
Okay. Any other questions or comments?
So, Paul, in order to kind of make progress to moving forward on these two drafts, what would you be needing? I do see that these two appendix, once you update based on what double gets updated, you need some reviewers. Apart from that, are you waiting on something?
For the framework draft, we just need to make changes based on this current discussion. And so I would say we can certainly, I'll certainly have those updated by the next meeting.
Okay.
But I wouldn't say it's ready for last call or anything yet, just because we're probably going to go around on this change. The tunnel draft sounds like it's not really going to have any significant impact from this discussion. So it may actually be closer. So maybe there's no change, but certainly I would welcome some feedback if you find anything in the document.
Cool. Thank you. That's it, right? I think those were all the presentations that we had for today. We had reserved close to 50 minutes for chairs to decide on how do we move forward. And based on the consensus that we reached, can we ask double authors to kind of update the draft with a new proposal, and when can we expect something on those lines for people to review?
I mean, I'm really motivated to get this done as fast as possible before everybody changes their mind. So but I obviously won't get anything done this week. I think in the next few weeks I should expect to have the double changes out. I think that working through all the details of the RTX red flex spec, that we will probably stage those out one at a time. We won't wait until all of them are done before we release a draft so that we can start reviewing them separately, but I think that those will take somewhat longer. So I don't really know right now, but soon, real soon.
Sure. Yeah, probably one approach is that since we are having a GitHub repo for PERC working group, having pull request for each of those things and put it out there for working group to review could be, you can get some early feedback on those things.
I might suggest that, since we kind of made this provisional agreement today, it might be good to schedule a virtual interim out a little ways to discuss the details, giving some folks a deadline to work towards, and giving us a chance to reconfirm things.
Yes, I think Cullen is agreeing to that. Sure. let's plan to let's give Cullen a couple of weeks so that he can produce some pull requests, and then we'll set up. In the meanwhile, we'll try to set up a virtual interim to discuss the details. So by IETF 100, if we are in good shape, let's see, we can make it a last call for IETF 100. Cool. So that's it for PERC at Prague in IETF 99. Thanks everyone for participating. You have 2 hours, like 1.5 hours left for yourself. 1 hour quarter. Thanks. So did everyone sign the blue sheets? No? Okay. So, Colin, the thing I'm trying to get my head around is what is the transition story when somebody invents a